Please let me introduce Dr. Franckx from the Federal Planning Bureau. So he's one of the key experts in our country making long-term forecasts on transport, and he has been developing a model for predicting the car fleet in Belgium. So maybe you can introduce what you're working on.
Okay. Good morning, everyone. So I work for the Belgian Federal Planning Bureau. For those of you who don't know the institution, we are a federal agency, so but we are independent from the government. So our task is to provide economic forecasts and economic studies for the federal institution, well, most of the time when we come in the news, it's because of things like macroeconomic forecasts, inflations, the budget, pensions, etc., etc. But we also have a small team working on transport, and the key task of that team is making long-term forecasts for transport demand in Belgium. And so I'm part of that team, and I work mostly on the car stock model. And the key task there is to really look at how policies that are related to the demand for cars in Belgium could influence that demand, and also, of course, push demand in favor of cars that are less harmful for the environment. So what I'm going to do today is to look in general at tax policies and how they can be influenced to green the car stock. So I'm not going to go into any technical detail of the models, because that would require quite a lot of knowledge in terms of economics and statistics. What I'm going to do is really give a general overview. So first I'm going to start with some key descriptive statistics. So this is really going to be just an enumeration of basic facts about transport in Belgium and cars in Belgium and the impact they have on the environment. So to put everything in context. After that, I'll give a brief introduction to European policies, because it's quite difficult to understand what Belgium is doing in terms of policies if you don't understand the European context, which is quite important. Then I'll describe car taxation in Belgium, and then you'll see that quite a lot of parameters in the Belgian car taxation system have as objective to influence the CO2 emissions or the local pollutant emissions of cars in Belgium. Also going to focus then in a separate chapter on the issue of company cars in Belgium, which is quite a big issue in Belgium and can have quite important impact on the environment. And then I look at two applications, two recent applications. First of all, I'll have a look at the total cost of ownership of cars and how these are influenced by tax policies. So you'll see that there are big differences in terms of taxation between private cars and company cars. And I'll show you that when you look at the impact it has on total cost of ownership, that total cost of ownership for alternative vehicles is quite different for company cars than for privately owned cars. Then finally, I'll have a look at a study we performed last year for the Ministry of Finance. So there has been the reform of company car taxation in Belgium, and I'll have a look at the impact it will have in the future on the demand for company cars in Belgium. Okay, so first the key descriptive statistics. First of all, it's important when we talk about transport to understand why transport is important when it comes to issues like climate change. So when you look at 2021, the share of transport in the emissions of CO2 equivalents is around 20%, which is a quite important share. But what's just as important is that if you look at the emissions per sector and the evolution through time, what you see is that there are several sectors where the emissions of CO2 have strongly decreased over time. That's certainly the case with industry, which is subject to the European emission trading system. But if you look at transport, well, so the emissions of transport have grown gradually from 1990 up to 2010. Then we've seen a small decrease, then again an increase, then again a decrease. So there's certainly no strong indication of important declines in transport CO2 emissions. And certainly it has now become the most important sector, which it was not 30 years ago. Okay? So this is an issue of concern. Also, today I'm going to focus specifically on cars. Okay, that's, well, mainly because this is the topic I'm working on. But of course, it's also important to put this in perspective compared to the other vehicles that are on the roads. Well, back in 1990, cars represented something like 60% of CO2 equivalents. And by now it has declined to around, well, somewhere between 50 and 60, but we expect by 2040 the share of cars to decrease quite substantially. And we'll understand in what follows, we understand why this is the case. Okay, but so what you see is that although heavy-duty trucks, of course, represent only a fraction of the total vehicle stock in Belgium, because heavy-duty trucks drive very long distances, and also, of course, because they are heavier, their share is quite important. It's much higher than the share in the total vehicle stock. A point that's also quite remarkable, and we could present a whole lecture on that as well specifically, is the share of light-duty trucks or vans, which is increasing through time. In Dutch, we even have there's a term for that, the camionnetisering van het vrachtvervoer, la camionnetisation du fret. I don't know if that's correct French, but why is this? Well, there are several reasons for that, but in general, the key driver for this is that regulatory constraints imposed on heavy-duty freight are much heavier than for light-duty freight. For instance, drivers of heavy trucks have to respect rest hours. This is not the case for vans, and also heavy-duty trucks in Belgium are subject to distance-based road charge, while vans are not, etc., etc. Okay, so this explains the increasing share of vans, which is a big issue because it makes road freight less efficient. But again, this would lead us too far to discuss all the implications.
But there you made the assumption that the cars would be electrified. The trucks will not be, but the
well, let's keep it. Well, okay, maybe okay. Well, one big difference is that when it comes to the share of cars, that's based on the car stock model of the Federal Planning Bureau. Mm-hmm. While in the case of trucks and vans, we use the projections of the FIDO, the Vlaams Instituut voor Technologisch Onderzoek. So these are really, for us, exogenous shares, and we know that but in that case, there's no explicit demand model for it. So it's really based on assumptions regarding the shares of an electrification in trucks. But there we don't have our own model.
Okay.
Okay. Another point is when, okay. Then the importance of cars is when you look at passenger transport specifically and you look at modal shares. So I have two representations here. That's the modal shares according to the number of trips. And this is the modal shares according to the distance that is being traveled. Okay. And so you see that when you look at the number of trips, something like 60% of trips are performed by car. But of course, most of the trips that are performed by car are longer than those that are performed by, for instance, by walking or by cycling. And when you look at the share in distance in passenger kilometers, we're talking about around 75% of passenger kilometers are driven by car. And this is an important figure because it shows really why claims that we could substantially decrease CO2 emissions by modal switch to train or bus is simply not very realistic. I mean, if you would say, okay, let's try to decrease the modal the number of kilometers driven by a car by around 1/3, so moving from 75% to 50%. Okay, so by cars that would be a decrease by 1/3 of passenger kilometer, which is quite huge. But then look at the perspective of train, what that would imply in terms of train traffic. That would mean that, for instance, that train traffic, I assume that everything, no, that's okay, that's just public transport in general. That means that public transport would have to move from 60% to 40%. That's a huge increase. And just look at the trains and the buses, what that would imply in terms of increasing capacity. Simply not realistic. Certainly, if you look at the train network, it's already saturated. When we look at certainly Brussels, which is really the kingpin in the train network in Belgium, the train network in Brussels is physically saturated. So it's not realistic to count on a radical modal shift. Even if people would want to do that, it's simply not realistic. So so if you want a radical decarbonization of the transport of passenger transport, it will have to come through changes in car technologies. Some stats also to show that how things have evolved through time, and the number of passenger cars in Belgium, of course, we started from a very low number just after the Second World War. But it's not as if the increase in the number of passenger cars has somewhere stopped. If you look at the last 20 years, you see that even compared to 2000, cars have kept on increasing in Belgium, have increased faster than the increase in population in Belgium. So the number of cars per Belgian person has kept on increasing over the last 20 years. And there is often, certainly in the United Kingdom and the US, a whole discussion about the peak car hypothesis. And a lot of people in Belgium people in the transport nerds in Belgium talk about it, but there's no empirical basis whatsoever in Belgium to assume we are close to peak car. Simply no statistics that show any tendency in this direction. Okay. Other thing that we have to keep in mind is the evolution of CO2 emissions of new passenger cars. What I represent here is the evolution of since 2007 of CO2 emission factors. So that's the grams of CO2 per kilometer of new cars in Belgium. Okay, very important. This is according to the test cycle. Why is it important to emphasize this? Because there's not one single factor for emission factors of CO2. The emissions of your car depend a lot on very specific circumstances, like, for instance, the number of people in the car, while you're driving with a cold start motor, whether your engine is already on fuel temperature, if you're driving in stop-go traffic in a city, or whether you're driving on a highway and you can drive at constant speed, etc., etc. Whether you have for instance, a bicycle on the roof of your car, etc., etc. All these things influence the CO2 emissions of your car, and that means that you somehow need a figure for your CO2 emissions. And what happens is that we, for the approval of cars, manufacturers have to follow a test cycle. Okay, which means that there's a prescribed routine that has to be followed Okay, and what is being tested is whether the CO2 emissions according to that test cycle follow do not exceed a certain amount. That does not mean that these are the CO2 emissions in real driving circumstances. And what we actually know is that in real driving circumstances, CO2 emissions will be higher. And a lot of people who claim a discrepancy between test cycle CO2 emissions and real driving and CO2 emissions in real driving conditions have increased over time. But anyway, so just for the time being, this is the evolution of CO2 emission factors over between 2007 and 2019. I've distinguished in the graph, I've distinguished between privately owned cars and company cars. Okay, what do we see? Some noteworthy points is that company cars have started with much higher CO2 emissions than privately owned cars, but these CO2 emissions have also decreased quite steeply since 2007, much more steeply than for privately owned cars. Why is that? Well, first of all, we'll come back to that in a minute. But what we know in general, company cars are much heavier than privately owned cars, are much more powerful. But since 2007, the tax system has provided incentives for decreasing the CO2 emissions of company cars. And this is something we can observe in the actual emissions. Okay.
What is ROB on your rest of Belgium?
Oh yeah. Okay. So the reason why I've distinguish between Flanders and the rest of Belgium is linked to the fiscal systems, because Flanders is until now the only region that has its own specific tax license tax and its own specific annual road tax. So this is why I distinguish between the two. Come back to that as well. Okay, but we see that in general the tendencies are more or less parallel, not completely, but more or less parallel. So we also see that there's a distinction between diesel and gasoline. So typically diesel cars are less fuel consuming than gasoline cars, and then so similar diesel cars will emit lower CO2 emissions. Well, just keep in mind that there are a few things we need to be able to explain. For instance, there is a strong decrease in the CO2 emissions of privately owned cars around 2012, followed by a steep increase. What has happened there is a system in taxes. Until 2012, you had was a sort of eco bonus for cars with very low CO2 emissions. That was abolished in 2012. And what you saw was in 2011 some strategic buying of these cars by people. And then, of course, once the premium was finished, these cars disappeared more or less from the market. Okay. What we also need to be able to explain, and that will come in a moment, is why the emission factors have increased again after 2015. Okay. Then, well, CO2 emission factors depend on a lot of things, but one of the things that's quite important is the powertrain of the car. Okay, well, the strongest tendency you see, whether it's for company cars, privately owned cars in Flanders or in the rest of Belgium, is the decline of diesel. Why? Okay, well, what you have is the context we had about 15 years ago was one where the European policy was to think that the best way to decrease CO2 emissions of cars would be to promote diesel. There were very few people thinking in terms of electrification. One of the reasons simply being that the batteries that existed 20 years ago were simply not up to the job. So the big gamble at the European level was we're going to decrease CO2 emissions of cars by promoting diesel. Gradually, people have started to understand it was a big cost for in terms of promotion of diesel, local air pollution. And so diesel cars emit more or used to emit much more particulate matter and nitrogen oxides than gasoline cars. And so policies gradually started to change, and fiscal advantage given to diesels were withdrawn. For instance, the excises on diesel cars were increased, etc., etc. And then the big turning point that was in 2015 when it was found out that Volkswagen had gained the test cycle in the United States up to the point that it was really outright fraud. And it became clear that was really big issue with diesel in terms of impacts on local air pollution. And this explains a series of measures that were taken, I think, for instance, of low emission zones in cities, or diesel bans in cities, low emission zones being quite often much more stringent for diesel cars than for gasoline cars. But this has led to a steep decrease in the popularity of diesel cars. Now, besides that, there is the issues of the other powertrains. Well, when you look at private cars up to 2019, that remained completely negligible. But you see here that in the case of company cars, by the end of the last decade, we saw a gradual increase in the shares of alternative fuel cars. So it's worthwhile zooming in on that. And so here I limit myself to the fully electric cars and the plug-in hybrids. So plug-in hybrids, just in terms of car technology. So you have the standard hybrids. Standard hybrids are cars that have both an internal combustion engine and an electric engine, where the battery of the electric engine is charged through regenerative braking. Okay. Well, in the case of plug-in hybrids, well, a plug-in hybrid vehicle is one where you can recharge the battery of the car, just like you can do with a full battery electric vehicle, and where the well, in principle, you would only use the internal combustion engine when the battery is flat, which is, again, this is not happening in practice, but let's go back to that later on. Okay, but so what we see in the case of company cars is a quite important increase in alternative fuels at the end of the last decade, and over the last 2-3 years, this has been confirmed. So we have now quite important shares of plug-in and hybrids and electric cars among company cars. We have had an important increase in the really recent past in the number of electric cars and plug-in hybrids. But that doesn't mean that all problems are solved. Another important time trend to keep in mind is evolution of maximum power of cars, because that's an important determinant of CO2 emissions of the engine. And what we see is that compared to 2000, in all size class, all engine size classes, the maximum power of cars has increased quite a lot. It has increased by more than 50%, by at least 50% in all size classes of cars. So cars have become more fuel efficient over the last 20 years in the sense that their fuel consumption per unit of power has decreased, but the maximum power has increased quite a lot over the last 20 years. Also, the weight of cars has also increased quite a lot. Again, by around 20% compared to 2000. And that's due to several phenomena. There is what is called the SUVization of the car park. So the ever increasing share of SUVs and pickup trucks is one element that plays a role. What is also playing a role is that an increasing number of car manufacturers are withdrawing from the small urban segment because the profit margins are simply too small. Okay, what we see now with The last year is that the Chinese have maybe found a gap there, and that the Chinese manufacturers are trying to fill that gap, but European manufacturers like Volkswagen, like Stellantis, have really expressed that they were no longer interested in that market segment because the profit margin on SUVs and other big cars, which were much larger. And it's wrong to think that just because we move to electric cars, that this increasing weight doesn't pose a problem. First of all, it causes a problem in terms of traffic safety. That's one thing. And also, the more heavy a car is, well, the more wear and tear it will cause while driving on the road. And also, when you have a heavier car, whether it's a gasoline car or an electric car, if you have an electric car, you will need a more powerful battery to move your car around. And if you look at the total life cycle of an electric car, it's not CO2 neutral. It's CO2 neutral while driving, but there is quite a lot of energy going in the production of the battery, and the heavier the battery, also the higher the CO2 footprint will be of the electric car. So it's not because we electrify the car stock that weight doesn't longer matter. Also, car manufacturers have often said that, well, okay, cars have become heavier, but that's because of things like safety, etc., which is not completely true, but it's partly true. Due to added safety features, cars have indeed become heavier, but also, so the power over weight ratio has also increased over time. So for any given weight, cars have become more powerful. Okay. Another key statistics is how the mileage of cars evolves through time. What we see here is for gasoline and diesel cars. So this is the age of the car. This is the annual mileage that is being driven on average in Belgium. And what we see is that the annual mileages decrease quite steeply with age, very steeply. So people often in environmental debates, there's discussion about the very old cars that tend to be more polluting than new cars. That's true. Well, certainly in terms of NOx and particulate matters, but also they are driven around much less than new cars. That's an element to keep in mind.
This is surprising for me because with the previous comment on the peak car, because when I look at statistics, I can see that the increase of cars of more than 17 years in Belgium is quite impressive over the last 5 years.
I'll come back to the issue of the age structure. So we, if you look at the average age at which cars are retired in Belgium, well, the first point is that you see that there's a very strong difference between company cars. Here I call it service cars and leased cars on one hand and private cars on the other hand. So gasoline cars are retired on average after 11 years, diesel cars after 9 years. But in the case of diesel, of leased cars and company cars, fleet cars, the age is much shorter. So what happens here basically is that these cars are exported usually to countries in Central and Eastern Europe.
This is totally contradictory to the intuitive feeling that we may have the feeling. I had the feeling that diesel car would long laster. Their engine is more resistant normally than gasoline cars.
Yes, maybe they are driven more per year.
Probably yes. This is for me.
It's based on it's based on figures of the car registry. So it's And just to give an well, these are estimated curves which gives the evolution of the life stages of diesel cars in Belgium. So I distinguish the evolution in function of the first owner of the car. So what you see here is it's a simulation. Suppose we have a car that was first purchased in 2010. And supposing the first owner was a leasing firm. So what happens? Well, here you have the probability that in 2012, the car will still be owned by a leasing firm. And what you see is that probability of ownership by a leasing firm decreases very steeply through time. Okay. Then the yellow curves give the evolution of the probability that it's owned by private individuals. So a lot of these cars are sold by these leasing firms to private individuals. But the black line gives the probability that's no longer in the car stock in Belgium. And so you see that this evolves almost together with the probability that it's owned by a private individual, indicating that quite a lot of these cars are sold really quickly for the export market. If you look at a situation where this car is first owned by a private individual, then you get a completely different picture. The probability that it's still in the hands of a private individual also decreases through time, of course, but much less steeply than for leasing firms. And when the first owner is a fleet, so it's a company car but not owned by a leasing firm, there's also a strong, the decrease is much stronger than for privately owned cars, but less steep than for leasing firms. At this point, to another element we'll have to keep in mind in the rest of this lecture is that what's happening with new company cars can have a huge impact on the fleet in general, because these cars are really sold on quite quickly to private individuals. Okay. And so this maybe to answer your previous question, when you look at diesel cars, for instance, so this gives the evolution of the stock through time, both the stock according to National Car Registry and the orange line gives our model simulations. So what you see is indeed that there are still quite a lot of diesel cars of 15 years and older that are driving around, but the decrease is quite steep after the peak around 10 years. So this gives the age structure in.
But the age structure is moving gradually.
Getting older. So cars in Belgium are getting older because they are of better quality. Cars are now have a longer lifetime than in the past.
One way of viewing it, I would say we are eating our capital. We have a stock of cars and it's growing older.
Yeah.
So basically we are living on the capital, not on the investment. We are using longer the car.
Yeah, yes, because they are of better quality in general.
Yes.
It's also better maintained than in the past. The maintenance is now much more with all the monitoring and the sensors in the engine. In the past, maintenance was according to very crude rules of thumb. But while now the things like the sensors allows optimized maintenance.
I would say it's not because they are better maintained. I would say because as companies have stopped producing small cars, people who want to have access to a car at a low cost, they have to buy older cars. There is not much options.
Yeah, okay, no, that's also
because I mean the evolution of the maintenance and so on. It's not so much on over the last 5 years, but you can see that the increase of the share of old cars is over the last 5 to 10 years. It's really impressive.
Yeah.
And it's not, I mean, it's mainly related to the increase of cost and the strategy of companies to stop producing small cars. This is my intuition.
Okay.
Not big studies.
Okay. Next stage, European emission standards. So there are some basic principles. So in terms of pollutants, and so European standards monitor several types of local pollution. So we're talking here about pollutants that have a direct impact on local air quality. And the most important being particulate matter and nitrogen oxides. Well, that's the most famous one. But European legislation also covers hydrocarbons and carbon monoxide. Okay. Actually, carbon monoxide has already been regulated since the beginning of the 1970s. It's not just for cars. So trucks and vans are covered by European legislation, locomotives, diesel locomotives, tractors, all sorts of off-road mobile machinery is covered by the legislation. Inland waterway vessels are covered, but again by separate directives. Okay. As I said before, when we look at compliance with the European directive, we have to perform it according to a test cycle, which means that in real driving circumstances, emissions will always be different from in the test cycle. No one disputes this. So that this is unavoidable. Whatever the test cycle that you invented, there will always be a deviation between real driving circumstances and the test cycle. The question is, of course, to what extent you can game the system. Now, these standards apply to new vehicles. They don't apply to the existing stock. Okay, so it's not because emission limits have become more stringent through time that countries can require old cars to retire from the stock. Which also puts a bit the big challenge you have whenever you talk about the low emission zone. Because in the low emission zone, what you're saying is, well, these and these cars can no longer enter the city center. And people could argue that this actually goes against European legislation. Because these cars cannot be withdrawn from the stock, but you could, city authorities can decide that they cannot enter the city. Which means that any decision about low emission zones always have to be justified in terms of local air quality, showing that you really, it's a measure that you have to take because locally air is very bad in a city. But it will always be subject to controversy. So the evolution of the pollutants. As I said, the first directive was actually dates back to 1970. But when we talk about local pollutants, we now talk about Euro classes. So the first Euro standard was introduced in the beginning of the 1990s, and the most recent update dates back to 2014 with Euro 6 cars. Okay, so through time, this the emission limits have become more stringent. So now there is currently quite a lot of discussion about Euro 7 standards, where there are negotiations going on between the European Commission, the Parliament, and the Council. Why? Well, because there are several parties, let's say, in industry, of course, but also some member states and some members of parliaments who think that we should skip the Euro 7 phase, because from 2035 on, it will be forbidden to put new internal combustion engines on the market in the European Union. And some people say that, well, this Euro 7 is going to put a lot of costs on the industry for cars that anyway, in 12 years from now, internal combustion engines will no longer be allowed to be sold in the European Union. So this is an unnecessary cost on the industry for a technology that is going to die out anyway. And some people even say that this takes resources away that could be used for the electrification of the car stock. So the stage we are in now is that just a few days ago in the Transport Committee of the European Parliament, a majority has voted in favor of watering down the proposal of the European Commission. One of the things that's really new in the Commission's proposal for the Euro 7 is that this would be the first time that would also be standards for the emissions of tires. Because people talk often about the exhaust emissions, but cars also have non-exhaust emissions, because tires while driving address wear and tear, and there are a lot of plastics that go in the environment. And this would be the first proposal that would also look at the emissions of tires. Of course, it does make sense to go through the detailed tables with all the emission limits, so I'm going to spare you that. Just keep in mind that there are different standards for diesel cars and for gasoline cars. And again, why? Well, all this has to be put in the context of the promotion of diesel. And when it comes to certainly the emissions of NOx, it's much harder for diesel cars to reduce the amounts of NOx than for gasoline cars, or at least it was in the past. Okay, and European legislators understood that if they would impose the same NOx emission limits for diesel cars as for gasoline cars, it would more or less kill off the European diesel industry. While diesel industry in Europe is very powerful, this is an important element to keep in mind, that the European diesel cars are really the best in the world. It's really the strong point of the European car manufacturers is that compared to American or Japanese or Korean, is that they are very good in producing diesel cars. They master diesel technologies very well. And so in terms of industrial policy, simply wouldn't want to kill off the diesel industry. And on the other hand, there was this idea by promoting diesel, we will decrease CO2 emissions of the car fleet. And if you want to understand the whole Dieselgate scandal in the United States, it was precisely because in the United States, the same standards applied to diesel cars and to gasoline cars. And Volkswagen wanted absolutely to enter the American diesel market. And this is why they gamed the system, because they knew that it was physically impossible to reduce NOx emissions. They gamed the test cycle. Didn't end well.
Not so bad for them at the end.
Well, yeah, but at least there were some executives who ended up in prison. Huh?
Yes.
So yeah. So okay, and of course on the positive side, it has led Volkswagen to make a quite radical shift in favor of electrification. But well, yeah, that's true. CO2 emission targets. Their time is also quite interesting. Is that it has taken a while before Europe has taken on a regulatory approach to CO2 emissions of new cars. And so at the end of the 1990s, the hope was that through voluntary agreements with car manufacturers, it will be possible to motivate them to decrease the CO2 emissions of new cars, but well, that failed. Okay, so in 2009, the first European directive was introduced to set a 2015 target for 130 grams per kilometers for new cars. This is not a target at the level of individual cars. There's a big difference with the Euro standard. So it's not something that is applied at the level of individual cars, but something that is at the level of the fleet that is sold in Europe. So car manufacturers have shown that among the cars that they have sold in Europe in a given year, that the average is less than 130 grams per kilometer. And in 2014, the targets 2021 were agreed, and so the emissions were set at 95 grams per kilometer. But you may remember from one of my previous slides that what we saw actually after 2015 was an increase in the CO2 emissions of new passenger cars. So what happened there? Well, in order to understand this, you have to look at the following point, that the 2019 regulation, which was discussed at length before, set new targets for reductions of CO2 emissions, but this time not in absolute numbers, but in reductions in percentage compared to the average in 2021. Now, suppose you are a car manufacturer and you hear this, and you know from all the discussions in the parliament that this is, and in the commission, etc., that this is going to be the target. What are you going to do in the years just before 2021? You're certainly not going to do more than what you're required to do by law. So what happened is that there was an increase in order, again, to game the system, to decrease future commitments to reduce CO2 emissions. That explains partly, that's one of the elements that explains why in the last 5 years before 2021, the CO2 emissions have continued to increase. Okay, and at the same time, it also explains why in 2021 we have finally seen a very strong increase in number of electric cars. Because cars get more and more heavy, and by around 2021, car manufacturers in Europe started to understand that they would not be able to meet the targets unless they would sell more electric cars. And so, well, I know from someone who knows from now, I have quite good contacts with someone who works at the International Council for Clean Transportation, who has direct contacts with industry. And they said very clearly that in 2021, car manufacturers started to panic because they saw that they were not going to meet the targets. And so they started to introduce very heavy discounts for cars sold to fleet, because selling electric cars or plug-in hybrids was the only way to meet the targets. Okay. Another two caveats to keep in mind when we talk about CO2 emission targets is that the CO2 emission targets are corrected for the weight of the car. So heavy cars, the CO2 emissions of heavy cars weigh less than those of small cars. Guess whose country who's behind that? Well, in French people, because well, we have a lot of big German company cars in Belgium. So French people, French person once, one French professor once said to me, "Vous les Belges, vous aimez bien les grosses allemandes." But it was meant in terms, of course, of the cars. So this is really 100% Germany who was behind this, and France and Italy who were opposed to this. But because Germany had a lot of car manufacturers that specialized in the manufacture of very heavy premium cars, this was Germany who lobbied for this. Another one that's quite contentious as well is that the 2019 regulation entered a sort of incentive mechanism that and as a result, that if as a car manufacturer you sell a lot of low emission, zero emission cars or very low emission cars, that discounts disproportionately meeting your targets, and so that you can sell more cars with very high CO2 emissions. Why is this controversial? So the idea of the Commission was this is going to provide other incentives for manufacturing fully electric cars. The problem is that it also includes plug-in hybrids. Okay, and now maybe it's time to come back to the problem with plug-in hybrids. So plug-in hybrids, again, there's this test cycle, and the test cycle makes assumptions on the share of kilometers that are being driven in electric modes. Well, we know that in practice, the actual share of electric kilometers is much lower for all sorts of reasons. One important reason is that, well, plug-in hybrids are often sold to companies as a company car. Until recently, you often had a situation where the user of the car could tank freely. He had a tank card. But in order to recharge the battery, he had to recharge at home and to pay the electricity. So, especially in Germany, there has been a detailed follow-up of this situation. People found out that sometimes plug-in hybrids will be sold on the second-hand market with the charging equipment still unpacked in the trunk of the car.
Yes.
And these cars tend to be heavier than fully internal combustion engine cars. So in practice, it's very doubtful that CO2 emissions of plug-in hybrids are really that low. So this is why important NGOs in Europe, like Transport and Environment and Greenpeace, have very much opposed this specific regulation, because it gives sort of fiat to car manufacturers to produce cars with officially high CO2 emissions based on the sales of plug-in hybrids, which don't really have very low CO2 emissions in practice.
This is increasing much more than pure electric cars. If I remember your graph, you have the increase of plug-in hybrid is even much steeper than electric cars.
Yeah. But in case of Belgium, we will understand when looking at the system, we also understand taxes, we will also understand better why. Okay, so let's continue. So the next chapter is going to look at the car taxation in Belgium. So first point is, so we'll see that a lot of taxes are based on the CO2 emissions of new cars. Okay, I said before, when you talk about CO2 emissions, it's always CO2 emissions according to the test cycle. And as research has shown that the discrepancy between the existing European driving cycle and real-world CO2 emissions had increased a lot through time. And now CO2 emissions for taxation are based on the new test cycle, the Worldwide Harmonized Light Vehicle Test, WLTP test. Okay, which of course means that and it has provoked important changes in the actual taxes. If you move from one test cycle to the other, you have to change all the reference values for taxes. Okay, so first category of taxes is the annual road tax and the license tax. So license tax is the tax you pay when you buy when you buy a car, whether it's a new car or on the second-hand market. Well, the annual road tax is something you pay annually. Since 1992, it's the regions in Belgium who can determine the parameters of these taxes, except, well, so Belgium has to be complicated, except for these cars, where the parameters of the tax can only be changed through an agreement between all the regions. Okay. Great. So in Wallonia and Brussels, at least until very recently, they just kept to the old system where the taxes are based on the taxable horsepower of a car. Okay. In France, it's different. So both the license tax and the annual road tax have a surcharge that depends on CO2 emissions and the Euro class of the car. I'll get to that in more detail in a second. Wallonia has also just recently reformed its license tax. That's maybe me remember from last year that the Walloon government had proposed a reform of both the license tax and the annual road tax to make it dependent on a car's weight, among others. So this provoked a huge backlash in public opinion. A lot of people saying, well, this is really just a tax to kill the SUV, which is probably not false. But it so turned out that the SUV had a lot of defenders. And so the government retracted, and so now the reform is limited to the license tax. And okay, of course, it's too soon to make any strong statement on the impact, but my guess it's going to be very small because the license tax is only a very small share of the total cost of ownership of cars. And if you can afford the purchase price of a SUV by BMW or Mercedes, you can probably afford the surcharge that you have to pay because of the weight of these cars as well. But okay.
When you speak about the leased cars, is it including all company cars or?
No, not only the leased cars. So fleet, if you have a company that has its fleet, that it's made available to the employees, that's not a leased car. That's a service car.
Okay.
But in the case of leased cars, well, the main reason is what they wanted to avoid a situation where leasing companies would move their headquarters from one region to the other in function of
It would be also the case for company cars. The company could decide.
Yes, but of course it's less flexible. If you are an industrial company based in the port of Antwerp, of course, you're not going to move your headquarters to Charleroi just to optimize that taxation. So the point in the case of leasing cars, it's really quite simple to move your headquarters from one address to the other. So this is more or less the logic behind it. So in the case of the license tax in Flanders, so well, this is the formula. Don't ask me how they came up with it. Never found any rationale for it. But so what it says is that the license tax depends on CO2 emissions per kilometers multiplied by the factor F, which depends on the fuel of the car. Again, don't ask me why they use these figures, but so there's a small subsidy here for LPG and natural gas cars, plus term X, which increases with time to represent technical progress. And so the idea is that with time, car manufacturers are incentivized to put cars on the market with ever decreasing CO2 levels. Okay, divided by, well, this denominator, which was equal to 250 until 2015, and then was decreased a bit, meaning again that the license tax would increase. All this to the power 6. Don't ask me why 6 and not 5 or not 7 or not 2 times pi. I don't know, but this is how it was. Plus, well, times 4,500. And plus a correction term. That depends on the euro class of the euro norm of the car. This, again, and this applies for all sales of cars, also second-hand cars. So if you have an old car with old euro class, you pay more. The idea is you pay more for diesel cars because they pollute more. And if you have an old car, you also pollute more. And all this times a correction factor for age, which again increases with age.
But you consider 2 times the age. In this case, you have the age in C and an X.
Yeah. Don't ask me to explain how they got to the formula. I have no idea. But this is.
Does it go in the same way? I mean, the LC, you basically. It's decreasing with time, this one. So if you have an older car, LC is decreasing, so you pay less in tax, but the X is increasing.
Don't ask me to rationalize that. It's it is what it is.
Oh, yes.
Also, so electric cars are completely exempted from the tax. And until 2021, this was also the case for CNG engines and plug-in hybrids with emissions of less than 50 grams of CO2 per kilometer. But again, these 50 grams per kilometer were really theoretical figures, which means that cars with actual quite high CO2 emissions were free of license tax. And note that until 2015, all plug-in hybrids were completely exempted, even if in practice they had very high CO2 emissions. But you see also, compared to the system in Wallonia or Brussels, that depends on that depended uniquely on the fiscal horsepower. You see the issue. Well, the issue is, of course, that if it depends on the fiscal horsepower, it is related almost directly to the price of a car. Here, the price of the car does not enter the equation, and there was a lot of controversy in Flanders concerning the distributional effects of this tax, because it would penalize cheap cars with high CO2 emissions, for instance. Now, if you look at the evolution through time, well, you see quite clearly the impact of the reforms. So it's quite interesting. Also, Brussels is the red lines, Wallonia is the blue lines. That there are differences between Brussels and Wallonia, showing the differences in the composition of the car fleets in the two regions. And then when you look at Flanders, so what you see is with the reform of the license tax in 2012, is that you see a very steep decrease for gasoline cars. And then after that, it increases through time. And then with the change of the denominator of the formula in 2015, you see a steep decrease for diesel cars as well. Okay, but on average, the values are not diverging a lot, so it's really about distribution. And the types of cars that are getting penalized are different.
In any case, it's around 600 euros for a car.
Sorry?
It's in any case, it's between 400 and 600 euros for one car. So it's very low as compared with
it's indeed very low. Of course, these are the averages. So there's a huge variation between cars, but that's the average. Then the annual road cars. And so until 2016 was the same system in Flanders as in Wallonia. But now there is a correction depending on the CO2 emissions of the car, and also depending on the fuel and the Euro class. Again, with the exemption of electric vehicles and plug-in hybrids under certain circumstances. And when you look at the evolution through time, here you see quite clearly, and that until 2015, things evolution is more or less parallel in the three regions, with the differences in the composition of the fleet being the only determinant. But then you see in 2015, with the reform of the road tax, an important decrease for gasoline cars and an increase for diesel cars, which was the objective of the reform. Okay, now let's talk about company cars. There's a lot of confusion about company cars in terms of terminology. And this is the definition we use at Federal Planning Bureau, and we still have discussions ongoing with the Ministry of Finance and with Stadbel and the Social Security Administration. I'm sorry. Hello? Hello? Okay. So there is a big discussion going on how to classify them. So what are company cars? Company cars are just all cars that are owned by a legal entity and not by a private person. Okay, and all cars that are owned by private companies enjoy corporate tax deduction. Okay, on top of that, they are subject to all the taxes that private cars are subject to as well. Next category we distinguish is salary cars. Salary cars are all cars that are made available to someone in the company free of charge or at reduced cost for private purposes. So this can be an employee, but it can also be the manager of the firm. Okay. So all these cars, or can be an independent worker. So all these cars are subject to a tax on the benefit in kind in the income tax. So the idea is if you can drive around with a car that you get free of charge from the company, that's a benefit in kind, and you are taxed in the income tax for this benefit of kind. Okay. On top of that, if the company car, if the salary car is made available to an employee, then companies also have to pay solidarity contribution to social security. And in that case, we speak about a company salary car in the strict meaning of the word. So these are not legal categories. This is just the categories that we will use just to make sure that we know what fiscal regime we're talking about. Okay, so what are the taxes on salary cars? Well, first important point, employees are completely exempted from contributions to the social security system for their private usage of the car. So that's a huge subsidy component, right? Because, well, of course, you so notice as soon as you are employed that the contributions to social security are quite important part that is being eaten of your gross wage. Second, well, employers, of course, in case of salary cars, according to the strict definition of them, employers have to pay a solidarity contribution, which depends only on CO2 emissions of the car, which is, well, good as an incentive for reducing the CO2 emissions, which means that solidarity contribution is completely disconnected from the value of the car and from the amount of kilometers you drive. Then, concerning VAT, so the deductible share of VAT depends on the amounts of kilometers that are being driven for private purposes. Okay. And then there's taxation of benefit in kind in the income tax. So this depends on that's product of the catalog value of the car. Then there's a coefficient that depends on CO2, the CO2 emissions of the car, and that becomes more stringent through time. Then all this is multiplied by 6 divided by 7. Don't ask me why, where the 6 divided by 7 comes from, but okay, so this is the formula. But you see again, there is an important disconnect between the value of the car and the way it's treated in the income tax. Okay. Then there's a treatment in corporate taxation. So the corporate, the deduction in corporate taxes depends on CO2 emissions of the car and on the fuel, according to this table. I think nobody knows by heart, but which would show that it depends, that it has changed through time and depends on the fuel. Also, well, there is in income taxation, there is the concept of disallowed expense. And disallowed expense is an amount that you cannot deduct from your taxable income. Okay. And in the case of corporate taxation, there is disallowed expense that depends on the tax amount of the benefit in kind. Okay. So, for instance, so if according to the calculation of the tax administration, your taxable amount for your income in kind is something like, let's say, 5,000 euros per year. It's a completely fictive example. Okay, there is an amount that is proportional to this 5,000 euros that will be added to your corporate income for taxation purposes.
So when a company is buying or offering an electric car, it's getting direct subsidies by the state. I mean, 120%. Yeah, any company has an interest.
It has been changed. So we have some, but until recently, this was indeed the case. Yes, indeed. So I remember a discussion I had a few years ago where there was a guy from a leasing company. He said, "Yeah, of course, we recommend to our clients to buy Teslas. They earn money by doing this." Yes. Yeah. This explains why you get these Teslas on the road, except for maybe a few people, all the Teslas you see are company cars.
Yeah. Sure.
I mean, as a CEO, you can show off your green credentials while being subsidized by the state for doing so.
Yes, I think that you have a rebate for some kind of electric cars in terms of corporate tax. I can understand it, but subsidizing at this level, it's totally neglecting the social and collective costs.
We'll get even further. Okay, so there have been changes. So first of all, this deductibility by 100% has already been abolished.
Mhm.
Then the fundamental changes that with the law on greening of the cars took off November 2021. It has been implemented from 2026 on. The deductibility of car expenses in corporate taxation will be reduced to 0, except for fully electric cars. And even for fully electric cars, the deductibility will gradually be reduced to 68%. Okay, so the most outrageous subsidy element will be taxed.
This applies to the fleet, not
Yeah.
the new ones. Yes. It's applying to the entire fleet.
Well, there are transition measures,
Okay.
but okay, I'm not going to go in all details. I think there's already quite a lot of information to process, and I'm not going to in all the subtleties of the transition process. Okay, now, okay, so I spent a lot of time talking about company cars, but is there an issue with company cars? Well, yes, there are several important distortions. So the basic point, of course, is when you talk about salary, certainly if you speak about salary cars, that they are made available to the employees. So it's a form of compensation. It's a form of income. Okay, but they are not taxed at the same rate as wages. Okay, so this is what economists call a distortion in the tax system, where you have two forms of income that, for completely arbitrary reasons, are taxed at different rates. Okay. Second point, when you talk about the fuel costs, so if you have a tank card, okay, as an employee, you can use it freely. Well, people could say, well, okay, but the employer has to pay for the fuel cost. So he has an incentive to keep his employees under control. But the problem is that this is deducted from taxable profits. So the free consumption of fuel by the employee is actually being subsidized by the taxpayer. And well, this is a loss of incomes, that this is one thing, and it also reduces any incentives to, well, it reduces very strongly incentives to save fuel company. Then there was also sorts of impacts on behavior of households. So there's a lot of empirical evidence that shows internationally, not just in Belgium, that if a company has access to a company car, it is more likely to have a second car at home. That households with company cars undertake more trips for private purposes, live longer, live farther away from their job, and also use public transport less often. And of course, it's not always possible to show causal links, but sometimes they are pretty obvious. And to give just one example, I remember the time before I had kids, so that's some time ago. But we sometimes, well, we always knew someone who had a company card with tank card. It was perfectly feasible to say on Friday evening, okay, let's just take the company car of X. First we go to Luxembourg because the tank card can be used until Luxembourg. There we fill the tank. We drive to Chamonix or Val Thorens or whatever. There we spend the whole weekend skiing, and then we drive back. And by the time the tank is empty, we are in Luxembourg and we fill it up again at the expense of the company. So we would go for skiing for a weekend completely, well, at the expense of the company, but also at the expense of the taxpayer.
Yes.
So of course, I don't want to moralize about this. That this is quite, people who have company cars often see that, who see this kind of things often see this as moralizing, the green dictates, blah, blah. No, this is really just how people respond to incentives, right? So there are in our tax system perverse systems that make that people overuse company cars. Another point also is that, well, company cars tend to be more expensive and heavy than than the kind of cars people would buy if they would have to buy them themselves. And of course, there is the impact on the budget. And there we have some quantitative estimates. The first quantitative estimate I know of in Belgium is from Michel Harding from the OECD, who estimates that the budgetary shortfall in 2014 was something between 1.5 and 2.5 billion euros. My colleagues Benoît Lehn and Alex van Steenberg in the Federal Planning Bureau have estimated it to be around 2 billion. And Vanina Prince of the European Commission estimated that it was around 4 billion euros, which corresponds to more or less 1% of GDP in 2016. And also to put it in perspective, the most recent figures I have seen of the budget deficit in Belgium are around 28 billion euros. So these are quite staggering figures, right? Also, you can ask now, the question is, why do we have such a wide range of estimates? Well, first point is we don't really know the exact number of salary cars, which may sound quite odd, but emphasis, and I think that's an important thing to keep in mind. If because the further you progress in your studies, the more empirical work you will have to do, and then work with data. And what you always have to keep in mind is that quite often we simply don't know exactly what is going on. And for instance, if you look at the car registry in Belgium, and so it distinguishes, when you look at the label owner, we know when a car is owned by a private person, we know when it's owned by a government institute, and we know when it's owned by a company, we even know when it's owned by a leasing company. But the car registry does not indicate whether it's a salary car or not. You cannot find that in the car registry. If you want to know what is going on, you have to use other data. Problem is fiscal data. Well, you can look at fiscal data, but in the fiscal data, you get the taxation of the benefit in kind. But if the benefit in kind also includes a laptop that you can use for private purposes, if it includes a smartphone that you can use for private purposes, etc., etc. Certainly in the case of people who are independent workers, who will probably also even have an office in their house that they also use for private purposes, you don't know exactly what is the worth of the car, right? Another possibility is to look at social security data, because well, there is the solidarity contribution for social security, which is fine, but it's paid by the company. So what you get is you get you get license plates, but it's an underestimate because you completely keep out all the company cars, all the salary cars that are being used by independent workers and by company owners. Okay, so you can put bounds on the figures, but you don't know the exact number. Okay, and now we are currently working on this with Ministry of Finance, with the Office of Social Security, and with Stadel. We actually have a meeting on Friday on this topic to try to make better links between the different databases. But it's not an obvious exercise. Another point is that if you want to estimate the budgetary shortfall, you have to make a counterfactual. You have to ask yourself, okay, what would be the cost of the car if it was and well, yeah, okay, then you have to think about issues like what is the lifespan of the car, because you have to calculate the whole cost of ownership. That depends on parameters like the lifespan of the car. It's found on the second-hand market. You have to look at the distance driven for private purposes, and again, none of these are parameters for which we have exact values. For this also even the distance driven for private purposes. I said the amount of value-added taxes that is deductible depends on the distance driven by for private purposes. So you might say, well, okay, we should be able to get this from tax data. No, because if you ask that, if you talk with the Ministry of Finance and you ask them, well, do you have data on the distance driven for private purposes? They say, no, we don't have that, because everything is based on rulings with companies. And these rulings these are confidential data. We make agreements with companies and saying we will assume that these are the number of kilometers driven, but that does not correspond to actual empirical regularity. So this explains why even if Harding, Leiden, Van Steenberg, and Princeton are all very smart people, they undoubtedly are, very competent people who did a very good job, they still get different figures with the same basic data, because there are gaps in the data that you need to fill with assumptions.
In any case, it's meaning that the state is spending something like 1% of its GDP without knowing exactly where it goes.
Yeah.
So it's an investment. It's a tax rebate is an investment by the state. You have to consider this. We are investing money in some kind of policy. And it's just, as I was telling you, the state is giving 2,000 to 5,000 euros, but we don't know exactly who gets this. We don't have any trace of this.
Yeah. So it is a big issue. And the number of company cars keeps on increasing. Okay, so here we have a sort of index. So compared to 2007. The number of company cars in Belgium, the total number of company cars has increased by 90% compared to 2007. So they keep on increasing, and more than half of the new cars that are being put on the market in Belgium are company cars. On the positive side, as shown you in the beginning, and that company cars are usually quite quickly sold on to the private market. And so the big question is, maybe company cars could be used as a tool to green the total car fleet. Because first of all, also there's this high turnover rate. So if there's a high share of electric cars among company cars, this could lead to a quicker electrification of the total car stock. And also, well, because company cars are driven quite a lot, that's an advantage for electric vehicles. Because electric vehicles usually have a high purchase cost but low usage cost. So we could use company car taxation as a tool to green the fleet. And again, I've repeatedly pointed out that there are strong incentives against high CO2 emissions in company car taxation, and that this explains why since 2007 the CO2 emissions of company cars have decreased more quickly than those of privately owned cars. Which puts us to the first application, because there's a lot of introduction. But now I think you've seen the context, right? So let's now move to the action. First of all, let's have a look at the total cost of ownership of cars in Belgium. Why are total cost of ownership calculations important? So quite recently, just 2 years ago, the International Energy Agency has pointed out that research has shown that the capital cost of electric cars is a very important barrier to the adoption of electric cars. The point is, of course, that if you are a rational person, you don't look just at the purchase cost of a car, but you look at the life cycle cost. You also look at the maintenance cost. You also look at the fuel cost, etc. And these tend to be much lower for electric cars. Okay. So this is why total cost of ownership is important from a private user's point of view. You look at the cost of the whole life cycle. For a policymaker, it's also important to have the total cost of ownership, because it gives you an idea how all the taxes you put in place can vary across different segments, can vary across different types of powertrain, how they can affect the total cost of ownership. And we'll see that it really makes a big difference. It's really a big deal. Of course, that doesn't mean that if you are a rational consumer, that you will only look at total cost of ownership. If you just buy the cheapest car, well, you buy a very basic model. Of course, you look at other things. You want to move people and goods around. So depending on the size of the family, you will attach different importance to the size of the car, to the trunk of the car, depending on whether you have a dog or not. The comfort level is important. The more you get older and the more problems you have with your back, the more the quality of the seats becomes important. Things like reliability are important, safety is important, and then just the prestige of the car can be an important factor. So the story never stops with the total cost of ownership, but it's an important element to have a look at. It doesn't tell the whole story, but it does tell quite a lot. So what is total cost of ownership? Well, it's the purchase price times the VAT on the car. It's the license tax. It's if you sell the car in 10 years from now, it's the residual value of the car, but that present value of it. Okay. Okay, then you have the recurring incomes. Okay, and well, what you see here, the formula you have here is when you have in the future during end periods recurring costs. That's it, always equal to X. Okay, so the net present value of recurring costs divided in year one, X divided by 1 plus I. In year two, it's X divided by 1 plus I squared, blah, 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 etc., etc. Till the final year, X divided by 1 plus I exponent N. Okay. And well, if you take the sum of it, this is just a geometric progression. Okay. And so what you have here is just the geometric progression of the recurring costs at the yearly basis. And so what you have, well, first of all, the fuel cost. And here we have to interpret fuel costs in the broad meaning of the word. So that would also include electricity cost on a yearly basis, and the annual fixed cost being the annual road tax, maintenance costs, and insurance costs. Okay, but that's the formula. It's quite straightforward. Not rocket science, but again, it's not obvious to calculate, not because the formula is difficult, but because of, again, gaps in the data. For instance, when it comes to the annual kilometers driven, nice, we have survey, the monitor survey, which gives us, well, okay, some data on the annual distance driven, but it does not give us data on how long the households intend to keep their car, to the extent that they know it. Also, pricing on second-hand market, we don't have them. So we can purchase databases that gives the price of the list prices of new cars, but there's no equivalent for transactional second-hand market, and a lot of transactional second-hand market is under the counter anyway, so we don't really know what's happening there. Additional problem is, okay, in the case of diesel and electric cars, there are some estimates of the values of second-hand market, but it takes a lot of field work to obtain these estimates, so it's not completely data-free. The big problem is with electric cars is that the market is not yet stable. We have a market where things are changing extremely quickly in terms of technology. Batteries are improving at an incredibly fast pace. And the problem is, okay, suppose now that you envisage to buy an electric car, but if you buy an electric car that was built 5 years ago, in terms of battery, we're talking almost about different products compared to the cars that are being sold now. So this should have a negative impact on the value of electric cars. On the other hand, there's also quite a bit of anecdotal evidence that now with the disruptions in the supply chain with the Corona crisis and with the invasion of Ukraine, that there has been a huge increase of demand on the second-hand market, which should have led to a spike in prices on the second-hand market. But it's really one big question mark. We simply don't know. Okay. Recently, the colleagues of the VIAS Institute, so the Road Security Institute, Belgium, have also published a total cost of ownership study in Belgium, assuming a very high resale value of electric cars based on the argument that batteries tend to have a very long lifetime. But okay, but that's an assumption. It's not really based on hard data. Okay. Okay. And again, of course, when you look at company cars, well, there are a lot of gaps that we have already discussed.
But in any case, you can say that an electric car is basically, as compared with traditional car, is based on coupling two different systems. A very low evolving system, which is the car, the engine, even the battery in a way, but all the hardware, software. And we know that over the last 30 years, the cycles for improving computer hardware, software, it's 2 to 3 years. I mean, you speak about batteries of 5 years ago, but who would buy a smartphone of 5 years ago in second hand? It's a dinosaur. And basically, your electric car is made of these two systems that you couple.
Yeah, so there are a lot of question marks. So what we did in this exercise, we simply abstracted from the second-hand market and just assumed, well, made a strong rationality assumption that the price for new cars reflects the expected evolution of the price on the second-hand market, which is a strong assumption, but it really shows the amount of uncertainty, the big uncertainty when it comes to cost of ownership. In at least in my experiences, the problem of what happens at the end. Okay. So one important advantage we had in our calculation is that we have access to database with all car purchases of the last 20 years with the list price of cars. I've been able to really look at the whole offer. Okay, and so the first thing I did was, okay, we have the distance are being driven by households in Belgium. And I've defined distance classes depending on the quintiles, really. Okay, so there's a distance class for households that drive less than 6,000 kilometers per year, those with 6,000 to 12,000, 12,000 to 18,000, 18,000 to 30,000, and 30,000 to maximum of 80,000. Okay, so I've defined distance classes, and in each distance class, I made an inventory of the 10 car models with the total cost of ownership. Okay, and I've per market segment, and I defined market segment as a combination of 2 parameters. Okay, so I distinguish between SUVs, van cars, so camionette. So it's really cars with that could also be used as a van. That's a typical example, Citroën Berlingo. Okay, and then family cars. So this means that there are 2 types of body types that are not included in the class. It's convertibles and it's sport cars. Why? And of course, these market segments exist, but they are not typical. It would be very expensive cars, and it would just and a lot of information for marginal market segments. So if you are interested in the cost of ownership of a Porsche, I can give that to you, but it's okay, it's not included in the graph. Then the second criterion is to look at the maximum power of the car. Okay? And again, so almost all cars are within the range 70 to 150 kilowatts. Again, okay, sorry for those who are interested in the Maseratis and the Bugattis, but okay. And so what do we see then? Well, the simplest graph to interpret is, of course, with the van cars, where we see that, well, this market segment is, when it comes to the cheapest models, it's almost completely dominated by diesel cars, right? Except in the lower power segments, where there are also some gasoline cars, but it's anyway, certainly it's all diesel and gasoline cars. With the family cars and the SUVs, you get a quite different pattern in the sense that looking at the, well, if you look at cars with lower power, okay, there it's mostly dominated by diesel and gasoline. If you move to the second segment, then suddenly the diesel completely disappears. But if you drive a lot of kilometers per year, and there are some electric models that become interesting in terms of total cost of ownership. Then next category, these are already quite powerful cars. Again, completely dominated by gasoline with, again, some electric models. And then quite interesting, if you really look at the premium, you get a much higher share of electric cars and even some gasoline plug-in hybrids.
So these are the Teslas.
For instance, yes, yeah. But so the gasoline plug-in, also gasoline plug-in hybrid. Well, gasoline plug-in hybrids really have the advantage is that because you have two engines, that their purchase cost tends to be very high. What we just see really is that, except in the total really premium segment, they are not very interesting in terms of total cost of ownership. Okay, but so there is an important message to derive from this. It's not. You cannot say that electric cars are better than diesel cars or gasoline cars. It really depends on how many kilometers you drive. It depends on the type of car you are interested in. And certainly, if you are interested in cheap models, in cars are not very powerful, but tend to be the cheapest. Electric cars are not really a good option. What's also interesting is if suppose we expand the analysis from the 10 to the 50 cheapest models, then you get a quite different picture. Well, again, and the camionettes, well, what's quite interesting is that you look at the most powerful segments for the camionettes is that there are not that many models on offer. Okay, that's one thing. But then what happens with the share of electric cars? Well, of course, because the 10 cheapest are included in this, the share of electric cars in each segment decreases, which points to another issue with electric cars, is there's not much diversity in the offer. As for some of them perform quite well in terms of total cost of ownership, but it's just not a lot of them. What also appears that if you open up from the top 10 to the top 50, is that you get some hybrid models, a much higher share of gasoline plug-in hybrids, and even some diesel plug-in hybrids, which is quite interesting because just 5 years ago, people said that diesel plug-in hybrids were dead as a market segment, but it's not that dead. Okay.
Can you come back to the previous slide?
Yeah.
So this is not the market share, it's the
No. It's the number of cars. It's the number of cars, it's the number of models within each market segment and distance class.
The devil's advocate, if you look at certain cities like Brussels that will enforce the diesel ban in 2026, maybe the diesel ban shouldn't be the issue, but maybe if I look at this graph, rather a ban on the size of the engine.
So for each of of the squares to come back to you take the catalog, you analyze the price of the car, you take the 10 cars with the lowest TCO. This is this. And the market segment is family, van, or SUV, or is it according to the power of the car?
According to
what is market segment?
the market segment is the combination of the body type and, and the maximum power.
All right. So for each of these bars, you sampled 50 models with
The 50 models with the lowest TCO.
Yes. So if you come back to the 10 models with the lowest TCO.
Yes.
How is it that you suddenly this amount of electric car for this specific segment? Because it seems to be generally increasing electric cars from left to right, which is.
Well, I don't know which individual models I'm talking about here. I can look it up, but.
So it's maybe one specific model, electric model in this category that fits a whole. That answers.
So it's not according to sales, right? So
yes,
of course, can discuss about where are the limits in different models.
Yes.
So if that's the question, if you have different variants of the electric Golf, where do you define an individual variant? So that's based on technical criteria. But it's true that there are certain cases where you could say, well, you could define this as two different models, where I would say this is just one model with there's a lot of. I cannot answer that right now because I would really have to dig in the database, and that takes.
It means that electric cars are more interesting with bigger cars than for much longer trips, especially more.
That's the general. That's the general pattern.
That one or two specific exceptions on this that are related to some.
So that's also. This is really consistent with what is being said in the press. That the big problem is, first of all, lack of diversity in electric models and lack of cheap models. And it's also the one point where the Chinese seem to have an important advantage. So if you because this is based on data from 2000, cost data from 2021, but in the last few months there has been a lot of discussion about the invasion of the European market by cheap Chinese models, and what you have is probably that certainly the German manufacturers, well, they're good in premium cars. They're always very much focused on the premium cars, and they have been completely blind to the small segment. They always said, you can't make cheap electric cars in the small segment. Well, the Chinese appear to be able to do it.
Because there you should have something, because people are making short commutes, short distances, so you don't need that much battery, and you can have a small car.
Yes, but no electric cars, and at least not European cars. Probably if I would repeat the same exercise in 1 year from now or 2 years from now, the picture will be completely different. That is an extremely dynamic market, right?
Yes.
So maybe let's.
Can I ask also?
Yeah, sure.
In these assumptions, I guess the evolution of both fuel prices and electricity prices will dramatically impact these calculations.
As well. Oh, I can. Well, if you want to, because I'm looking a bit at the clock, right? And I don't think I will be able to talk about reform of company cars. But what I can show you when I'm finished with this is to give a short overview on a different presentation of the changes of the last year. I have 2 or 3 slides about that. It could be interesting to have a look at this one.
Yes, because this is based on the price of electricity from the market. It's not based on the electricity you buy on
well, there's a discussion also. Okay, that we had. This is one of the things we well, okay. If you look at the price of electricity on the market. And so we don't look at specific cost of fast chargers, etc.
Okay.
Okay, no, that's true. That could be an interesting. This is not the first time I get this remark, and it could be an interesting exercise for sensitivity analysis. Okay. Okay. Okay, so some other slides I would like to show. So to put a bit of perspective on the calculations I've just shown, these are the sales per market segments. Yeah, and here these are the figures for Wallonia. Why? Well, because of the differences in taxation between the 3 different regions. All results always have to be shown for specific regions. So for private cars, I've given the example of Wallonia, but the general conclusions are also valid for Flanders and Brussels. Is that if you look at the sales of the market segments, is the market segment with the very high maximum power. Actually, you don't see that much sales. And most of the sales are very much concentrated in the lower power classes. And so you see that the market segments where electric cars, if driven a lot, have a certain market advantage, have actually very low sales. And so this puts the figures in the previous slides in perspective. So the electric in the mass market, electric cars really don't perform well on the private market. Sorry. Another point also that's interesting to look at is the range of electric cars versus their total cost of ownership, where you see there's a weak tendency where cars with the longest range also have the highest total cost of ownership. It's not a very strong relation, but it's still important because it shows that it's not just that there are not that many, that there's not a very large diversity, but also that the models that are in the cheapest segments tend to have a low range. Another way to look at it is to, well, instead of looking at distance classes, is to look at one specific distance that is annual driven. It's 50,000 kilometers, which is around the median, and to give the total cost of ownerships and to give the box plot of total cost of ownership. So what is a box plot? In case you've never seen it, well, for instance, let's have a look at here. So the box plot for gasoline cars in this market segment, what the thick line here in the middle shows is the median. So 50% of gasoline cars in this market segment have a lower total cost of ownership, and 50% have a higher cost of ownership. The lower bar is the first quartile, so 25% of cars have a lower total cost of ownership and 75% higher. And this is the third quartile, so 75% have a lower total cost of ownership and 25% a higher total cost of ownership, which means that the box plot contains 50% of the total cost of ownership for this powertrain and for this market segment. And so the small lines give the outliers to above and below. Why is this interesting? Well, because it shows the danger of looking just at central values. And so for instance, if you take this market segment, so you see that the median for electric cars is around the median for gasoline cars and much lower than the median for diesel cars. Okay, but if you look at the total distribution, you see that that 25% of diesel cars have lower total cost of ownership than this median value for electric cars, and that 50% of gasoline cars also have lower total cost of ownership, and that again that the range that is on offer for diesel and gasoline cars is much higher. So this really a danger of that you should never really look only at the central value. And the same in this range again, total cost of median total cost of ownership of electric cars is very low, but you see that there are much more cheaper gasoline cars than cheaper electric cars compared to the median for electric cars. Yeah. And again, you see this about we see a confirmation and just other words of the pattern we had already seen before. There is just very little diversity in the supply of electric cars. It's very much concentrated around a few models. Now, this with company car taxation. So in okay. In everything I show from now on, I will assume that all company cars are salary cars. And so I take into account the fiscal regime for a salary car in the strict meaning of the word. But just an important element of uncertainty in this total cost of ownership, in the sense that, well, the discrepancy between the benefit and current use for tax purposes and real value for the employee, there is a huge gap. So this means there's a huge implicit subsidy in terms of wages. Of course, companies do not just offer this to allow their employees to have a higher net income, and their actual purpose is to be able to offer a lower money wage. So when we look at the total cost of ownership for company cars, we should also take into account the fact that there allows some savings on wages. And well, I'm not going to explain how I did it. So if you are interested in papers that are freely available online, I've developed a methodology to at least have a lower bound to the amounts of to the amount of money that can be saved, okay, through offering a company car. So I'm going to present the total cost of ownership of company cars under two assumptions. One in which there is no impact on the wages, and the other under the assumption that wages are affected. You see that the conclusions are completely different. And well, of course, well, in the case of company cars, we will assume that they are resold after 3 years at 1/3 of the price. It's okay. Okay, so first, let's just look at again at the 10 models with the lowest total cost of ownership. And again, let's not spend too much time on the van cars where it's really again completely dominated by diesel and gasoline cars. But what gets interesting is when you look at the share of electric cars. So what's quite obvious is that just through the advantages in corporate taxation, that electric cars have a huge advantage compared to what you have for privately owned cars. Have a much higher share of cheap electric cars, and this is also this is just taking into account the direct impact on total cost of ownership. But now assume that we also look at the tax advantages for the employee and the impact it can have on the wages. There you get a completely new picture. Now a lot of new colors emerging. For instance, you see a lot of plug-in hybrids that were completely absent until now, but thanks to all the advantages based on the official CO2 emissions of plug-in hybrids, we see now that thanks to that, plug-in hybrids emerge, both gasolines and diesel. We also see some, surprisingly, some hybrid gasoline cars. I wouldn't spend too much time on the issue of hybrid gasoline cars because anyway, nowadays almost all new cars have some hybrid elements in them. So the distinction between conventional gasoline cars and gasoline hybrids is becoming vaguer and vaguer. But what I think is the really big deal here, it's the gasoline plug-in hybrids.
It's purely an artificial effect.
Which is an artificial effect, given that in real driving circumstances, the CO2 emissions of these cars are much higher. And this is why, well, some people argue that plug-in hybrids can be a sort of transition vehicle, but
They will stay.
in practice, it seems more that they cost a lot of money to the Belgian taxpayer, and well, but for very little environmental benefit.
What is surprising is that you have, France, Germany, or Japan would not produce these cars only for the Belgian market.
No,
so you have distortions in the other countries too.
Yeah, but it's all, well, a lot of countries have premiums for cars with very low CO2 emissions.
Yeah.
Which is changing quite dynamically as well. So Germany has just put an end to some tax advantages, but France has its eco bonus. So this is text from a webinar, Dutch speaking seminar I gave a few weeks ago. So what has changed since 2021? So first of all, the fact that the Chinese, according to Ursula von der Leyen, are flooding the European market with cheap electric cars, and that, well, now European car manufacturers at least have announced that they intend to work on cheap electric cars. Another thing is that, well, in terms of energy price, so we know that 2022 has, for obvious reasons, been extremely volatile in terms of energy prices. But not just energy prices. Also, if you look at the materials, if you look at the lithium-ion batteries that are used for electric cars, the prices in 2022 have increased for 7%, which is the first time in about 20 years where they have decreased. Prices have decreased. If you look at battery packs, so for lithium-ion, if you look at the price per kilowatt hour, they have decreased by something like 90% in 20 years, which is an incredible decrease in costs. Never have thought that 30 years ago, but batteries are an incredibly exciting topic to work on nowadays. But so they have for the first time increased in 2022, but they have again decreased since March 2022. So again, it's not just an increase, it's just been a very volatile market. And if you look at the evolution of the purchase prices, well, we see that between 2020 and 2022, the average price of purchase price of electric cars has continued to decrease, and much more than for other models. And if you look at the private cars, so these are with the cost data of 2020, so with purchase cost data and with fuel costs of 2020, and you see indeed a different figure. You see a much higher share of hybrid gasolines, and you see more plug-in hybrids compared to 2021. The reason why I have emphasized the results for 2021 is simply that, well, 2022 has been extremely volatile due to war circumstances. Of course, it could be that war will be our future for the next 5 years. We don't know. But for the main presentation, I have emphasized prices in a more stable market, assuming that this will be what we will return to in the long run. But you see indeed that as I said previously, that this is an extremely dynamic market where things change very quickly. And this is what you get for company car market, and again with an even higher share of plug-in hybrids. But the general story remains the same, and is that compared to private cars, plug-in hybrids are much more advantageous for company cars, given all the tax incentives.
Thank you very much for
Thank you
the
very much.
very interesting talk.